Hello Python coders! Welcome back to our Python tutorial series. In today's video, we are going to delve into converting integers to bytes in Python. Let's get started. Before we begin, let's remind ourselves what integers and bytes are in Python. In Python, an integer is a type representing all numbers. It can be of any length and isn't limited to a size. Bytes, on the other hand, are immutable sequences of integers, each in the range of 0 to 255, typically used for binary data representation and manipulation. Python's int class provides a build method to underscore bytes. To convert an integer to a bytes object, the syntax of the method is follows. Here, length specifies the length of the byte. The byte order defines the byte order as either big for big endian or little for little endian. Big endian and little endian terms describe the order in which bytes are stored in memory. In big endian format, the most significant byte is stored first at the lowest address, while in little endian format, the least significant byte is stored first. These conversions affect data interpretation. The sign parameter is optional. Its default value is false when set to true. It allows the use of negative numbers. Let's see how we can use to underscore bytes method to convert integer into bytes. We get the result as x04 x01. It is the hex of this number. Here we have specified the byte order as big. We will see what happens when the length parameter isn't set correctly. Here let's attempt to convert the integer 10 into bytes. But we will set the length parameter to 1 instead of 2. As you can see, it raises an overflow error with the message "in too big to convert." This is because the length parameter is too small to hold the byte of the gave integer. What happened here? The number 10 to 5 requires 2 bytes for storage. We specified the length as 1. Python raises this overflow error because it can't fit the data into the number of bytes specified. Let's understand that the other parameter of byte order. Let's change it back to 2. We will change it from big to little of this parameter. So the byte order changes the arrangement of bytes. Right, so previously it is 0 for 01, but now it is 0104. Let's explore the last parameter, that is signed. The signed parameter allows for the conversion of negative numbers. Provides if set true. It treats the integer as a signed number. So let's first make the number as a negative number. and then we will make signed as true. This result is the byte representation of the negative number, meaning 10 to 5. It is 2's complementary representation of this negative number. If the sign parameter is false but the integer is negative, it will throw an overflow error. Let's change it to force. It shows overflow error, can't convert negative into unsigned. We have demonstrate how to convert the integer to byte in details. And then let's make a reusable function to convert the integer to bytes. Here the function is like this. We define a function integer into bytes. The parameters are integer byte order and the signed optional parameter. The critical part of this function is assigning the right length of the byte so that we don't need to manually specify length in the argument. The number of bytes needed to store this number. It's computed using nym.bitlength and then plus 7, and then floor divided by 8. The bit_length method returns the number of bits required to represent the number in binary, excluding the sign and leading zeros. Adding 7 and then performing floor division by 8 is a trick to round up the number of bits to the nearest byte. For instance, if bit_length is 17, the result should be 3 bytes. Because 1 to 8 Bs require 1 byte. -1 to 16 Bs require 2 bytes. And 17 to 24 Bs require 3 bytes. But 17 floor divide 8 would give 2. So we add a 7 before floor dividing to correctly round up. Let's try this function, then it will give us the answer correctly. Okay, it brings us to the end of today's tutorial. We've learned how to convert an integer to bytes in Python, dived into the intricacies of byte order, and even learned how to handle the common errors effectively. If you found this video helpful, do give us a thumbs up, share it with your friends, and subscribe to our channel for more insightful Python content. If you have any queries or suggestions, drop them in the comments section below. Your feedback drives our content.